So today we're going to be covering the column, covering questions 5 through 17. So without further ado, let's jump into the first one. So we are going to be looking at number 5. Okay, so with number 5, let's go ahead and take a peek at what we're working with. The population of a certain bacterial growth over time in minutes can be given by this equation. Population is equal to 32 times the natural log of t minus 5, where t is greater than 0. How long will it take for the population of the bacteria to reach 520? Okay, so what we're looking at is we have this equation, 32 natural log of t minus 5. Now here's the thing. This minus 5 is not included in a set of parentheses, so I'm assuming that the natural log is only of the t, where t is greater than 0, and what we're trying to find is when the population is 520. Okay, so that's enough to start with. So let's take a look at how we would work this. So with the population of 520, I'm going to immediately plug that in. Let's work this right here. So 520 is 32 times the natural log of t minus 5. And remember again, we're assuming this minus 5 is not part of that natural log. So 2 steps to isolate the natural log. I'm going to add 5, which makes that a 525, 32 natural log of t. And then I'm going to divide by 32. 525 doesn't divide by 32 evenly, so I'm just going to leave it as a fraction is equal to the natural log of t. And how to get the t out of that expression, I need to remember what natural log is. So 525 over 32 this is a log base e of t. A natural log is just a normal logarithm with base e. So what I'm going to do is I'm going to come over here and I'm going to convert this into exponential form, which will isolate my t for me. To convert it to exponential form, I'm going to drop the base and say e to the power of, swap. So drop the base and swap. E to the power of 525 over 32 is equal to t. Awesome. So that's all we need to do. So I'm going to estimate what this is. Now, if it wants an expression, if your question is asking for what is the generic expression, it's going to be that. But we're going to assume that it wants an actual time in some sort of unit. And so let's see what we get. So I have, let's see, make sure we know how to type this in. I have e to the power of 525 divided by 32. Ooh, I got a lot of minutes. So I have, let's see, that's 13,339,631.84 minutes. Or I could get, let's see, that is 222,327.197 hours. Or 9,263.633 days. Or 25.380 rounded years. Okay, so depending on the units, the original time in minutes is 13 million minutes, and that seems like an excessive amount of time for this population growth to grow from 32 to 520. But let's remember what the shape of this natural log graph is. If we take a peek at that natural log shape, let's graph this. So we're going to come over here and say 32 times the natural log of x minus 5. And if we look at the graph, we see that it shoots up really quickly, so we're expecting that to come into hand. But let's zoom all the way up to when the population hits 520. So let's set our window of x min of 0. And if we have an x max of that, let's go all the way out to 13, 339, 632 is going to be our x max. Our y min, we're going to say we're going to start at an assumed population of 0, and we're going all the way up to 520. Ooh. So what we see is, yes, that first part of the graph is all right here. It's a steep, steep, steep curve, but as it starts getting some time, it flattens out, which is why it takes so long to crank up from that initial jump to that last little peak. It takes longer and longer the higher we go. So depending on your answer, depending on your units, you can put any one of these things over here. So that was question 5. Let's take a quick look at question 6. Okay. So question 6 says solve this equation. We have 28 equals 2 e to the 0.42x minus 7. Okay, so we're going to solve this one pretty much the same way that we just did the other one, except for instead of a natural log, I have a base e. I'm going to try and isolate this base e by adding the 7, which gives me a 35 equals 2e 0.42x. I'm going to divide by 2. 35 divided by 2 equals e to the power of 0.42x. And I get this right here. Now, with this right here, I'm going to attempt to convert this into logarithmic form to isolate my power. So if I convert this to logarithmic form, I drop the base and swap. Drop the base, log base e, and swap. So log base e of 35 over 2 is equal to 0.42x. Awesome. And so from this point forward, we know the log base e is just a fancy way of saying natural log of 35 over 2 is 0.42x. I divide that by 0.42. So the natural log of 35 over 2 divided by 0.42 is equal to x. Now again, depending on if you want an expression for your answer, this would be your value. Or if you'd like to approximate that, I could go ahead and I could type this in. So let's see what, let's back out of this. If I have numerator, natural log of 35 over 2, close numerator, divided by 0.42, I get roughly 6.81, and that rounds up to a 5. So depending on if we want a rounded approximation or if I want an actual value, there we go. So that was question 6. Let's take a look at question 7. Okay, so question 7, we want to convert rectangular coordinates into 3 different polar representations of that point. So let's go ahead and write this down. So negative 2, 2 root 3. So we're using polar coordinates. Now, if we remember, with rectangular coordinates, what they do is they tell us a direction of where to go on the grid. So if I have negative 2, 2 root 3, I'm somewhere right here, and I end up creating a triangle. So I have negative 2 and 2 root 3 as my x and my y. Now, polar coordinates give a slightly different story. They want to tell us the distance traveled, and I'm going to write this as theta. So polar coordinates give me the distance and the angle from the axis. So they want to know how long this unit is, and the second thing they want to know is what is this angle measure. So it gets you to the same point by saying what is the degree of rotation and how far away from the origin is it. Boom, we get to the same point. So 2 things we need to figure out. First, we need to figure out what this hypotenuse is. So let's start by using the Pythagorean theorem. A squared plus b squared is c squared. So my a squared is going to be negative 2 squared. B squared is 2 root 3 squared. And c squared is going to be that distance. How far away from the origin is my point? So I'm going to say d squared. So 4 plus, let's see, 4 times 3 is d squared. That's 12 plus 4 is 16. And so this gives me a 4 is equal to d. Now, when we look at the 3 different representations, taking the square root, we know that we're dealing with a positive and negative aspect. One of the things that we will come back on is that we always generally assume distance is positive, but that negative can also be used in polar coordinates. So step 1, done, we found out what our d is. It's either positive or negative 4. Step 2 is I need to figure out what that angle is. And the way to figure out that angle is I have to use my trig relationship. So if I have, looking at ka toa, I want to know what angle, and now the angle is going to be right here, gives me a relationship of 2 root 3 over negative 2. That's going to be opposite. Over adjacent, I'm looking at tangent. So the tangent of this angle is going to be 2 root 3 over negative 2. So in order to pull out that theta, I'm going to have to invert this. So the inverse tangent of 2 root 3 over negative 2 is going to give me that angle measure. So there's no rule one way or the other if I need to give degrees or radians unless asked. Generally, we're going to think about it in degrees, simply because degrees is more of an application-based. Radians is more math. Depending on your question, we're going to take a look at that. So let's clear out of this. So I'm going to look at what is the inverse tangent. So second tangent, the inverse tangent of numerator 2 root 3, closed numerator, divided by negative 2. Oh, double check our mode. Right now my mode's in radians. We said we were going to look at degrees. So let's try that one more time. Boom, I get negative 60 degrees. Now, if I have negative 60 degrees is my theta, that might cause us to pause because we were like, hold on, that's not negative 60 degrees. Negative 60 degrees is this right here. And so now using these two pieces of information together, we can see that if I'm dealing with a negative 60 degrees, which is right here, so negative 60, I'm going to use that negative distance because I'm not going along this direction, I'm going against it. So I can still go negative 60 degrees, but negative distance. So one possible polar coordinate is, let's see, a distance of negative 4 with negative 60 degrees. The other option is if this is 60 degrees, well then that's also 60 degrees, which means my original red theta is going to be 120. Because if I have 60 over here, I have 120 left of my straight line. So option 2 is I have a distance of 4 and a positive value of 120. But that's only 2 out of 3. Well, with polar coordinates, remember, I can loop around a second time. So I can use my distance of 4 yet again and just add a full circle to this degree measure, which is 480 degrees. Boom. So I have 3 different polar coordinate form of that point right there, which is represented by that in rectangular form. Awesome. So that's question 7. Let's take a look at question 8. So we're going to start off on a new sheet of paper so we can save some space here. So question 8, let's see what we're working with. Okay, so question 8, we want to convert the polar coordinates into rectangular coordinates. So for 8a, we have these polar coordinates of negative 8, comma, 2 pi over 5. And for b, we'll come back to that here in just a moment. Okay, so when we look at this, remember, we know that polar coordinates give me the distance, and this gives me the angle. So what I know is that if I draw my Cartesian plane right here, I know I have an angle of 2 pi over 5, so I need to figure out where on the circle this is. Well, if I'm dealing with fifths, I know this is pi or 5 pi over 5. So I'm not quite at 5 pi over 5, I'm at 2 pi over 5. I know that this is half of that, so this would be 2.5 pi over 5. So I'm actually somewhere in right here. So this unit right here is 2 pi over 5. My distance is negative 8. And that says, oh, hold on, I'm not actually heading in that direction. I'm heading in the negative direction, which means my negative 8 spits me out in this direction. So this is my distance of negative 8. So if I have a distance of negative 8, okay, that's 2 pi over 5. This should be 2 pi over 5. Let's do this in blue. And if that's 2 pi over 5, and that's 5 pi over 5, that's going to give me a whopping total of, let's redraw this little area. I know this is of unit 8, and I know my original angle, created right here, is 2 pi plus 5 pi is 7 pi over 5. Awesome. So if I want to convert this to rectangular coordinates, well, all I need to do is figure out what my x and my y are. So what is my x and what is my y? Okay. Well, I can either use this little piece or I can use that little piece. It doesn't really matter too terribly much as long as I know whatever value I get for my x, make sure it's negative. Whatever value I get for my y, make sure that's negative. So let's convert this into just a trig triangle. Okay. So if I have this angle measure, and we're actually going to stick with the 2 pi over 5 angle measure, I need to figure out what my adjacent over my hypotenuse is. So I'm going to bust out the SO, CA, TOA. Okay. If the adjacent over the hypotenuse, to find my x, I'm going to use cosine. So the cosine of, let's see, 2 pi over 5 is equal to the adjacent over the hypotenuse. Solve for x. 8 cosine of 2 pi over 5 is equal to x. If I need an expression, this expression will get me there. If I need to estimate, x is equivalent to, let's go ahead and check this out. Clear all that. So x is equivalent to, let's make sure my mode, this time I'm in radians, convert back to radians, is 8 times the cosine of 2 pi divided by 5. Okay. So x is roughly 2.472. Actually, remember what we just said. Because x is heading in the leftward direction, that's going to be a negative 2.472. And technically speaking, I shouldn't have boxed that up because that's not the full answer. I need to figure out my y. So now my y is going to be the opposite over the hypotenuse, or sine. So the sine of 2 pi over 5 is equal to y over 8. Or 8 sine of 2 pi over 5 is equal to y. Again, that's my y value. If I wanted to evaluate the rough approximation of that, well, sine. I get roughly 7.608. Again, I know that y is in a negative direction, so it's going to be a negative. So my answer, if I want exact units, would be negative 2.472, comma, negative 7.608. If I wanted exact units, no rounding, I would say 8 cosine of 2 pi over 5, comma, 8 sine of 2 pi over 5. There we go. So that's A, converting polar coordinates into rectangular coordinates, simply just finding the distance of that new triangle. So that's A. Let's look at B. Okay. So B is going to be, let's still do 8B, 7 comma negative 73 degrees. Okay. So this one, because it's in degrees, might be a little more friendly to do. But let's go ahead and set up our coordinate system right here. I know I am dealing with negative 73 degrees, which means I'm going somewhere in this direction. This is negative 73 degrees. And I know I'm going in along that line, because I'm going in a positive direction, a length of 7. Which means that the triangle that I'm going to create right here looks like this. So 7, negative 73. I need to figure out what is my x and what is my y. Now my x will be positive, my y will be negative whenever I plug in my values. So I'm going to bust out, let's zoom in just a tad bit right here, my SO, CA, TOA. If I want to figure out my x value, that is going to be adjacent over hypotenuse cosine. So the cosine of negative 73 degrees is equal to x over 7, or 7 cosine of negative 73 degrees. That's the exact value, the approximate value. Let's see, I got to switch over to mode degrees this time. So 7 cosine of negative 73. 2.04, and that 6 rounds up to a 7. For my y value, that's going to be opposite over hypotenuse. That is my sine. So sine of negative 73 is equal to y over 7, or 7 sine negative 73 degrees is equal to y. My absolute answer, my approximate answer, if I plug that in, is going to give me a y is approximately equal to negative 6.694. Let's double check, make sure our signs are right. X is positive, y is negative. We're dealing good. Okay. So I have two possible answers here. If I want exact, 2.047, negative 6.694. If I want exact, 7 cosine of negative 73, comma, 7 sine of negative 73. Whichever one we need. Okay, and so that leads us to question 9. We're going to start 9 on a new sheet of paper to give us some space again. So question 9 says, given the vector u, which is 2, negative 4, and the vector v, which is 3, 1, let's find u, and this is the magnitude of u. So just like polar coordinates, let's go ahead and set this up. So I know u is 2, negative 4, and v is 3, 1. We want to find the magnitude of u. So what is u? Okay. So similar to polar form, what's going on here is these vectors, I have an x vector and a y vector. Normally vectors are shown in 3 forms where I have some sort of 3-dimensional aspect in space, but when we're looking at the double bar of u, I'm asking what is the magnitude of this? I know how far rightward and how far up or downward I'm going, but what is the length of the vector? So let's take a look at that. If u is equal to, so if u is equal to 2, 4, I have, let's draw it like this. So 2, so I have 2, negative 4. My resulting vector is doing this, kind of just like polar form. I want to know what is the length of that. So to find the magnitude of this vector, I literally just take the Pythagorean theorem. Or if I wanted to use it in the formula, it's the square root of 2 squared plus negative 4 squared. If I wanted to plug it into the formula, I would get that. But again, it's just set up using the Pythagorean theorem. So if I were to set that up, I know u squared is equal to 2 squared plus negative 4 squared. So if I square root that, I'll end up getting this over here. So either way, 2 squared plus negative 4 squared, boom, I get the same thing after one step. So 2 squared is going to give us a 4 plus 16. I'm looking for the root 20. If I want to simplify that, I have 2 possible answer choices. I could say the magnitude of u is root 20, or I could rationalize that and say the magnitude of u is equal to, let's come over here. So 20 is 4 and 5. I know the root of 4 is 2 root 5. Awesome. So the magnitude of u is equal to either one of those, unsimplified or fully simplified. Okay. So that was 9. Let's take a look at 10. Okay. So 10, I need to find the direction angle of the u vector. So I want to find the direction, 10, of u vector. and I know that u vector is equal to 2, negative 4. Okay? So again, just like in polar coordinates, we now know what the length of u is. It's 2 root 5. I want to find the direction. What is the angle measure? So in polar form, we found the distance either here or here. That's exactly what this is asking, just in vector format. So if I have this triangle with 2, negative 4, I want to find whatever theta is that will give me that. So I'm going to break out the SOHCAHTOA and see what I have. Well, I have the opposite and the adjacent, which means I'm going to be using the tangent. So the tangent of my angle is equal to negative 4 over 2, or when is the tangent equal to negative 2? Okay. If I rewrite that to isolate the angle measure, this is the inverse tangent of 2 is going to give me that angle. So if I want an expression and to find the exact thing, that would be it. That is going to be my direction. However, if I want some sort of approximation, let's figure out what this will give us. Okay, so let's check our mode. Right now our mode is in degrees, so I'm going to put our angle in degrees. Okay, the inverse tangent of 2. My direction is going to be roughly 63.43, rounded up, 5 degrees. One of those two, if you want exact or if you want an approximation. Okay. So number 10, the direction of u prime. If I'm looking at number 11, now I'm finding the direction angle of the vector v. So now vector v is equal to, let me say it was 3, 1. 3, 1. Okay, let's book that one. Okay. So this vector is up here. Hold on. That is a negative angle measure. There we go. Negative degree. Almost missed that. The vector right here is of 3, 1. So 3, 1. What we want to find is we want to find this angle measure, because I know the vector v v vector is that right there. What is the angle measure created by a vector v? Oh, okay. So I'm going to break out the SOHCAHTOA, figure out, well, if I have that angle, I have the opposite and the adjacent, it's going to be the tangent. So the tangent of that angle is equal to 1/3, or the inverse tangent of 1/3 is equal to that angle. This is the absolute answer. If I want to approximate it, let's see what we get. Okay. So the inverse tangent of 1/3, we're still in degrees now, is going to be roughly 18.43. That's rounded up to 5 degrees. And unlike before, we're not going to make that mistake. I know that is a positive degree, so I keep that. And there we go. So that's going to bring us to question 12. And let's take a look at question 12. We're going to start again on a new sheet of paper. Give us some more room. So number 12, we're going to convert the following complex numbers into trigonometric form. So if we remember, trigonometric form is a variation of polar form. So I have this number, so -5 plus 2i. Let's go ahead and get started on this one. So if I look at this number on the complex plane, what I'm looking at is I'm looking at a number on x and I of -5, 2i. So -5 and 2, I'm going left on the real number axis and 2 off onto the lateral axis. And trigonometric form, like I said, similar to polar form, I want to figure out what the magnitude of that is. We're going to call this the modulus in this form. And then I also need to figure out what the angle measure right here is. So 2 things first. First thing, I need to figure out what that is. Now, this is going to be a squared plus b squared equals c squared. But we call this distance in trigonometric form the modulus which is denoted by an r. So r squared. Otherwise, the other two are just going to be plugged in as 2 squared plus negative 5 squared. Let's give us a 4 plus 25, which is 29. So root 29 is equal to my r. There we go. So our modulus is root 29. The second thing we need to figure out is that angle measure. And so to figure out that angle measure, we're going to use this angle. I'm going to come over here and I'm going to bust out the SOH, CA, TOA. That angle measure has the opposite and the adjacent, which is the tangent. So the tangent of that angle is equal to 2 over negative 5, or the inverse tangent of 2 over negative 5 is equal to that angle. Okay, so let's spit out and see what that angle is. Let's see what mode we're in. Okay, so we're in degrees. So the inverse tangent of 2 negative fifths is going to be negative 21. Now that negative 21 should throw up a slight red flag, because what it did was it said, hey, there's the angle it just gave you. It gave you this angle. But it doesn't really hurt, because I know if that's negative 21, that's positive 21. I'm going to take 180 degrees and subtract that anyway. So let's add 180 degrees. My leftover right here is that. So I'm going to write this down. So my angle measure is 158.199 degrees. Okay. So that being said, if this was in polar form, I would simply write parenthesis square root 29, comma 158.199 close parenthesis, done. But in trigonometric form, what I want to do is I want to produce my complex number, which is a plus bi, using these two values. So for my a, my real number axis, I'm going to try and produce that negative 5, which according to my angle is going to be the adjacent leg. For my complex leg, that according to my angle is my opposite leg. Okay, so if I want to produce that negative 5 using an adjacent angle, I'm going to say this is going to be my modulus, which is root 29, times, let's see, adjacent is cosine of 158.199 degrees. And then I'm going to add my modulus, which is root 29. This time I'm going to plug in an I, because I have to denotate that is in the I-ward direction, of the sine, because the opposite is going to be my sine trig function, sine of 158.199 degrees. And then the last thing that we do when we do trigonometric form is we tend to factor out that root 29. So trigonometric form denoted by z is root 29 cosine of 158.199 degrees plus I sine of 158.199 degrees. And there we go. So that was number 12. Let's take a quick peek at number 13. Number 13, we're doing the same thing, except for I'm converting 3 and the negative root 3i. Okay. So again, trigonometric form is very similar to polar form. I'm going to show where this is on the complex plane with real and lateral. I'm dealing with 3 and then negative. So I have 3 and negative root 3 right here. So two things. I want to figure out what is this modulus, and I want to figure out what degree of rotation produces that. So a squared plus b squared equals c squared, which again we said is denoted by an r for the modulus. Otherwise I'm going to take 3 squared and add it to a negative root 3 squared. So 9 plus 3, 12, root 12. If I wanted to rationalize or simplify this a little bit more, I could factor that out into a 4 and a 3, which is 2 root 3 is equal to r. Okay, so my modulus is 2 root 3. The second thing I want to figure out is what angle produces this. And so I'm going to use this as a secondary angle. My angle deals with opposite and adjacent, which we know. So, ka, toa, dealing with the tangent right here. Okay, the tangent, the opposite, and the adjacent. Okay, opposite over adjacent, which means that my inverse tangent of negative root 3 over 3 is going to give me my angle measure. Let's see what that will produce. Let's go ahead and clear this. So I'm still in degrees, so inverse tangent of negative root 3 divided by 3 gives me negative 30. So my angle is negative 30 degrees. So if that's negative 30, that will still produce that same angle measure. So I can either use negative 30, or if I wanted to use the positive value, I could say my angle is 330 degrees, which is 360 degrees minus that little blurb. Again, trigonometric form, what we're going to do is we're going to say, I want this to be an A plus BI format. My A format is 3, which is my adjacent side. My complex term is my opposite side, which deals with cosine and sine respectively. So I'm going to say my modulus, which is 2 root 3, cosine of 330 degrees, plus 2 root 3, I, sine of 330 degrees. And again, denotated by z typically. I'm then going to factor out that 2 root 3. So z is equal to 2 root 3 of the cosine of 330 degrees plus I sine of 330 degrees. There we go. There's trigonometric form for number 13. Awesome. So that's going to bring us to number 14. And again, we're going to pop off a sheet of paper to keep ourselves some room. Okay. 14. Same setup is going on here. Converting this to trig form, which is a version of polar coordinates. So negative 1 minus I. So on my real number axis of real and lateral, I'm dealing with negative negative. Okay, so that's a negative 1, and that's a negative I, which is again a negative 1. I don't really need to use the trig function to figure out what angle that is, because I know if that's 1, 1, that should be a root 2, because this is a 45, 45, 90 triangle. So already I know that that modulus is going to be root 2. And I know that angle is going to be 45 degrees plus 180. So my angle, which is right here, is going to be 180 plus 45 is 225 degrees. So I can jump straight into my final answer and say, hey, if it is in A plus BI format, my A, which is my real number, is my adjacent, which is cosine. My B, which is my lateral number, is my opposite, which is sine. So I get root 2 cosine of 225 plus root 2I sine of 225. I tend to factor out the root 2. I say my trig form, which is denotated by z, is root 2 parenthesis cos sine. Boom. And that's number 14. And so that's going to bring us to question 15. And so let's take a look at question 15. So I have two vectors. I have D and E. So the vector D is negative 3, 3. And vector E, which is the vector 4, 5. Okay, now these are two variable vectors. And I need to figure out 2D and minus 3E. So I'm assuming that this is something of a typo. I should have a 2 outside of the vector notation. So we're going to say, okay, so what is 2 vector D minus 3 vector E? Okay, so we're just combining these vectors together. So the first part of this is if I need to figure out what 2 vector D is. Well, 2 vector D is just I multiply each of these by 2. So that gives me, this is going to be negative 6, comma 6. And I'm subtracting 3 of this, so I'm going to multiply each of these. I'm going to get a 12 and a 15. And if I subtract them, I'm taking vector 1 and subtracting vector 2. So negative 6 minus 12 is going to give me a negative 18. And then 6 minus 15 is going to give me a, let's see, negative 9. And there's my resulting vector, is right there. Awesome. In essence, what happened is I'm plugging these 2 vectors together. You can do a tips tail method, but this method works pretty well. Then if I jump down to number 16, whoop, I'm dealing with, I want to find out what, let's see, vector D, let's write this down again, is negative 3, 3. And I want to figure out what 3 magnitude D vector is. Well, we know when we find the magnitude of a vector, I just need to figure out what the distance or what the magnitude is. So as of right now, my D vector is negative 3, positive 3. So negative 3, positive 3. I need to figure out what this length is right here, and I'm going to triple it. So to figure out what the magnitude of this vector is, which is denoted by that, I'm going to say a squared, b squared, c squared. So that is 3 squared plus negative 3 squared is distance squared. I'm going to rewrite that as distance. So 9 plus 9, 18, root 18. Okay. So if I want to rewrite that in simplified form, that's a 9 and a 2. So 3 root 2 is D. Whoop. Okay, so that gives me part 1. So if I want to find 3 times the magnitude of D, that's literally me saying what is 3 times 3 root 2. And so 3 times the magnitude is going to give me a 9 root 2. Don't have any units, so there we go. Let's take a look at number 17. Okay, so 17 I have, let's see, let's copy down vector E, which is 4, 5. Oh, not even within the screen there. Negative 4, 5, or 4, 5. And I want to figure out what 4E is. So the magnitude. Okay, so the first thing I know is that I can rewrite this as what is 4 times the magnitude of this E vector. And so let's write out what E vector looks like. So E vector is over here because I have a 4 and 5. And what I want to do is I want to figure out what is this length right here. So I'm going to use the good old Pythagorean theorem. Okay. So that's going to be a 4 squared plus 5 squared equals my distance squared. 16 plus 25. So that's going to give me a 31, 41. So the root 41 is my distance. Okay. So if I want to figure out what that is, this is quite literally saying what is 4 times root 41. And that's it. And there we go.